We're going to be making a to-do list app, which I'm sure you've seen on tutorials online. I know we've got a lot of people in the room at the moment, and I have a feeling most people aren't going to be able to get a seat. But don't fret, because we've got a full recording of what we're going to be doing, and on top of that, you can just sort of follow along and watch the demo, and all the code's going to be available online for you later. So if you can't get a seat and you can't follow along, that's okay, it's all going to be online after. So what is Node.js? So firstly, the simple explanation is that it's JavaScript that runs on the server. How many people here have used JavaScript before? Okay, fair enough. So we'll give like a really short sort of like demo on how to use JavaScript. If you've done C, which I'm assuming a lot of you have probably done a bit of C before, you'll be able to pick it up pretty quickly. It was created by Ryan Dahl in 2009 using Google's V8 JavaScript engine. So it's not new anymore, but it's still in widespread use, and all sorts of companies use it, from Google to Microsoft to Amazon and more. So what it is it's basically a server-side runtime environment for JavaScript with an emphasis on scalability and a maximization of throughput. And what I mean by that is it's going to be using a lot of asynchronous I/O. What does that mean? Basically, what it does is, instead of waiting for a response for some kind of input-output operation, like reading from disk or accepting a request, basically it just returns from the function that it uses to get that, and it'll call back when it's got the result that you want. And so a consequence of this is that it's very fast, and so you can make very fast server-side applications very easily, and that's really one of the reasons why it's so popular. So what is Angular? I'll let Emmett take this part over.
Okay. Angular is basically JavaScript, but with a lot more structure and clarity. So a long time ago, a lot of people decided that JavaScript on its own wasn't enough to fully support a full-scale web application. So a lot of people started making frameworks that you can use to structure your application in a more efficient way. So Angular is one of these. It's a product of Google, and it's a selection of JavaScript code that comes with a set of pre-built tools and code that you can use to structure your application. So Angular, from versions 2 onwards, uses TypeScript, which is a dialect of JavaScript that includes types. Generally, following the structure of a web application or a web framework like Angular makes your program your web application a lot easier to actually build and structure. You can break these rules if you want. Probably don't do that. But generally it makes your life easier.
So why learn Node.js and Angular? So this is a web app workshop, so the obvious answer is to make web apps, but there are more reasons than just making web apps to learn Node and to learn Angular. So firstly, Node.js, like I said, lets you develop server applications quickly. JavaScript is a very easy language to learn, very easy language to pick up and just start using. So Node.js lets you make server-side applications using that. So it's really easy, and we can make a REST API, which is talking over HTTP. We're going to do that in less than an hour, I hope. It lets you develop performance server applications easily. This is because it uses a lot of asynchronous I/O. So when you're accepting an incoming request, for example, you're not waiting for that request to finish. You're basically accepting the request and then returning straight away and going back to doing some other tasks. This is a little bit mind-bending at first if you're familiar with C or another sort of procedural language, but I think you'll pick it up pretty quickly. So Angular allows you to install a structure into your web application. So you're not just using your basic HTML, CSS, and JavaScript. You're now able to componentize the work that you're doing. So you can reuse parts of your web app over and over and over. So thus, it allows you to make elegant, reusable front-end code and use a great range of pre-built tools. There's all sorts of generators and things like that we'll be using and that you can use in the future with your future Angular projects. So what we're going to be doing is we're going to be making a to-do list, like I mentioned. The front end is going to be in Angular 6. It's important to remember that because there's Angular 1.6, Angular 2, Angular 4, there's no Angular 3, and then Angular 6. The backend will be in Node.js. We're going to be using the latest version of Node.js. And this is our Git repository. All of the code is going to be in here. If you don't follow along, or if we don't manage to get through all of the work in time, because we're going to be really fast, don't fret, it's all on the Git repository, and we'll have a recording for you. So without further ado, let's get started. So what we're going to do first is we're going to install Node.js. So I've installed it already on my laptop, but what you can do is you can just go to Google. Just Google Node.js and it'll come up. Now I'm just going to sort of move on to let you all do that in your own time. I'd like you to download the latest version, 10.10.0. The difference between the two is not all that significant. All the syntax is the same. You'll be able to use most of the same libraries, but the most current one is going to have the most up-to-date features. So download that, run the installer. It'll be a script inside of a zip file. I'll just sort of move on because I know we don't have a lot of time to do this. And again, I must stress, if you're not following along, if we're moving too quickly, don't worry, it's all here. So the first thing we can do is we can open Node in interactive mode, right? So to do that, once you've installed Node, I'll give everybody a little bit of time to do that, but I better move this over. Man, okay. We can open Node in interactive mode. Who's used Python here before? Yeah. So you've used Python in interactive mode before. You basically can just open it up and start typing in your commands, and Node is no different. Now, I know some of us aren't familiar with JavaScript, so I am going to go through some of the basics of JavaScript right now so that we're all sort of on the same page. For the most part, the code is pretty similar to C. So if you've used C, it's also relatively similar to Python as well. If you've used those, you'll probably be able to pick it up pretty quickly. So, for example, how can I make a variable in Node and by extension in JavaScript? So we use var. The var keyword indicates a variable. So this is us creating a variable. And we're going to call it, let's say, name. Okay? We've just created the name variable. It's uninitialized, meaning if I query its value by going like this, it's going to come up as undefined. Now, undefined is kind of similar to null. It indicates no value. So we've given a variable, we've called it name, doesn't contain anything, so let's actually assign a value to it. So you do this just like you would in C. Name equals Nick. Now name contains Nick. And again, if I query that value, it'll tell us what it contains, right? Now, unlike in C, yeah?
Can you zoom in a little bit, please?
Yeah, sure.
If you do Control-Shift+, it'll increase the...
Nope, it won't. That's all right, I'll use the other terminal. Okay. Is that a bit better?
Yeah.
Cool. There we are. Okay. So remember, variable name equals Nick. You can use single quotes or double quotes for variables. It's all the same. So unlike in C, JavaScript does not have a strong typing system. So for example, in C, if you said something was an int and then you tried to put a char into it, you get an error. Or if you try to give a string to a function that only accepts an integer, you'll get an error. JavaScript doesn't have such a distinction. So for example, I can now set name equals 76. And our name does contain 76. So this allows us to be more expressive in the code that we write, but it also allows us to have a little bit more flexibility, with the added danger of perhaps we don't get something of the right type. So that's how we make a variable. Let's create a function. So we'll start with a function that doesn't have a name, and I'll show you a couple different ways to write functions. And we can console.log. This is like print. Hello. Okay. So now when I go hello, it says hello. It prints out whatever we had in the console.log. Okay. Now there's another way to write functions. This is going to look a bit weird. Don't worry too much if this doesn't make too much sense. I want to show you it so that you've got an idea of what it looks like. Okay, so I've created a variable that contains a function. This here is another way to write a function. So we've got func, and we can call it like this. 1, 2, 3. And it returns 6, because it returns A plus B plus C. Right? So this is just a different way of writing functions. We might use this in the future, we might not. I just want to make sure everyone's clear on what that looks like. So we can also create constants. Oops. Now A contains 5, it's similar to a variable, but you can't change it. Alright? That's really the limit of all of the JavaScript we're going to need, but as we go along, I think you'll start to pick it up. Even if it's not making too much sense, we'll make sure that the recording has everything that you need and you can follow along at your own pace. So if we go back to the slides, if you're in Node interactive mode, you can exit it by pressing Control-D, and that'll take you back out to your terminal. So Node comes with its own package manager. If you're using Ubuntu, you'll probably have like apt or something like that. Or if you're using another distribution, you'll have some kind of package manager. Node has its own package manager as well. So what a package is it's a library of code that you can use, and you can even write your own packages. So what we're going to be doing is we're going to be creating our own Node package, which is going to contain all of our script files, and that's going to be our to-do list server. So when you install Node, you'll also be installing npm. That's your Node package manager. To create a package, we're going to use npm init to create a package in the current directory. So I recommend you make a new directory for this because we're going to be putting all of our code inside of here. So once again, sorry, change branch. Yeah, that's fine. Backend new. So I'm now in an empty folder, and what I'm going to do is I'm going to go npm init to create a new package. Now, Node is going to create like a package file for us called package.json. JSON stands for JavaScript Object Notation. What this is a special data file that allows us to contain all sorts of structured data. So we can call the package anything we want. I'm just going to leave it as all the default. You can give it a version, description, entry point, whatever. Recommend you just say, yeah, this is all good. Just press enter until npm exits. So what we're now going to do is we're going to see we've got off this file package.json. So this is what you should do whenever you're going to make a new Node application. All right. Now, we can also install packages from the internet using npm install. So this is similar to apt install, but it only applies for the package in your current directory. Okay. So what we're going to do is we're going to install some packages. They're going to be added as dependencies to our new homemade package. And whenever we want to npm install our own package, it's going to install all the dependencies for us. So this is nice because if I'm working with Emmett, for example, and I send over my code to him and I say, hey Emmett, I'd like you to install this package, he can just go npm install and it'll install all of the packages that I npm installed, and then he can use it as well. So that means you don't have to include all your dependencies as part of your code. So you can have very compact server-side applications like this. Now, we use --save to add them as dependencies. If we just do npm install, we'll just download them. This might not make a lot of sense right now, but I'll show you exactly what I mean. So let's start by making an Express server, all right? So what we're going to be doing is we're going to be using a package called Express. This is used for creating your own web servers, basically. So I'll show you what I mean by npm installing. So if I npm install --save Express, and I press enter, what npm is doing is it's going to the npm repository, which is on a web server in California, I'm sure, and it's going to download the latest version of Express and install it as a dependency of our package, right? So this is going to appear in a folder here. So now that I've LS'd, you can see Node modules as a directory has just appeared. This contains everything we've installed. So if I npm install something, it'll be in here. And to prove to you that it's there, there's a whole bunch of other stuff, but Express is right here. So we've installed that, and we've installed all of these dependencies. So now that we've installed it, we can start using it. And I'll show you how we can actually begin executing some of the packages that we've installed. So what I'm going to do here is I'm going to open this up, and I'm using Atom. You can use whatever editor you like. But I'm going to make a new file called index.js inside of the directory of my package, okay? So new file, index.js. Okay. So this is going to be the entry point of our application. Think of this as your main.c if you've used C. All right? Now, what we're going to start doing is we're going to import Express by going const express equals require Express. So what we're doing here is by requiring something, we're saying we want this package and we want to use everything inside of that package as part of our application. So this is kind of similar to your hash include in C, but in this case we're putting it inside of a variable called express, okay, with a capital E. Now, the capitalization doesn't matter, but for constants like this, you should have a capital letter so that you know that you can't change this, all right? Yeah. Yeah, there you go. Can everyone see that? Cool. So now that we've got this express object, because it's going to be an object, it's actually not just one thing, but it's several data items lumped together in an object, we can create an application. So var app equals new express. Let me double check that that's right. Yeah, no, sorry. Express. So now we've created our application object. This is kind of going to be the backbone of our application. So basically, to recap, we have imported Express, and we've got the package name there. We've put it into an Express object, and we've created an application. So I'll show you how to run your application. This application isn't going to do anything, but I'll show you how we can get it working. So now we're in our repository. We're going to go node index.js, and you see it just runs and it does nothing. So what we're doing is we're giving Node our index.js file, and it's executing it from top to bottom. So if anyone's used Python, it's similar to going Python and then typing the name of your file, right? So so we're going to make a hello world application now. So it's just going to be, you can open up your Express app, and this is going to be your backend server, and it'll say hello. So the way we add routes, what we're doing is we're adding a route to our web server. We go app.get. We give it the path that we want to route for. So for example, if we go localhost / it's going to redirect us to this route. And we need to give it a function. Now, for those of you who are familiar with C, this is going to look really weird and really scary. But what we're doing is we're giving it a function as a parameter to this other function, right? Okay. So what we've done is we've set up a route. It's going to respond to a GET request on the / URL, and it's going to send back the string hello. So what this is doing is when we get requests that come into this route, it's going to send back that response. And so these two objects are request, which we usually just abbreviate to just rec, and response, which we usually abbreviate to just res. Now, we've set up a route, but our application isn't actually going to be listening for any connections yet. It's sitting there, it's set up its route, but it's just going to run away and be finished. So in order to fix that, we have to go app.listen. 3000, and now we're also going to give it a function. This function is going to execute once it starts listening for a connection. So once we've got our application server up and running, this function is going to run. Okay, so this is our basic hello world, all right? I'll show you the difference between when we're res.sending and console.logging and everything when we run it. So it's now running. We executed the file. What it's doing is it's going down, and it's going down to app.listen. And when it goes into app.listen, it just waits. Now that it's running, it prints out console.log now running, and it's now waiting here on our computer for an incoming connection, because you can see it's not finished executing. So to demonstrate what's actually happening, localhost 3000. Oh, yeah, sorry. There we are. I opened up the page in my web browser, and it sent back this string. That's what res.send does. It sends back whatever you give it, right? So what happened was app.listen was waiting, an incoming client came in, and we sent back a response. So I'll let you see this for a moment again. Whoops. So it's really that simple. So you can see how we can build entire web applications like this by just including a whole bunch of routes that send back different data. And this is all in JavaScript. So now that we've got our Hello World application, we're going to move on and we're going to start making some more complicated routes, because we can see this is what we've got. We've got routes and we're now listening for a connection. And that's really the bread and butter of what Express is. So what we've learned is app.get creates a route that responds to a GET request. We can also respond to post, put, delete, and whatever other kind of HTTP requests we want. And app.listen opens your Express server and listens on a given port. So that's why we gave it 3000. That's the port that it's listening on. That's what that means. So I want to give you a little bit more information about what this mysterious rec and res objects are. So this is the request object. This represents the incoming connection. So when I send a request to my server to say, I'd like you to get me the page at / whatever, that rec object represents that incoming connection. So you can see all sorts of things in that object. It'll contain things like the IP of the person making the request. It'll say what the request headers are in HTTP. It'll say the port that they're coming from, things like that. And the response object represents what we're sending back. So this is usually denoted res. It contains information about the response that we're about to send back, and that's why we use res.send to send the response back. So we can set up headers to return and things like that as well. If you're interested in experimenting, try printing those objects by console.logging rec and res. You'll see it prints out a whole bunch of stuff. That's what's inside the object. It's all request headers, HTTP versions, things like that. You don't really need to understand all of that, but I want to give you some background. So now we're going to make our web app for real. So we're making the backend first. Each to-do we're going to create will have an ID, a title, a body, and a flag marking it as complete or incomplete. So what we're going to have is we're going to have a list of like tasks that we need to do, and when you click on it, it'll say completed. And then you can uncomplete it or whatever if you want later on. So we can represent this using JSON, which is this object notation. So I'll type this into Node and you can get an idea of how we can use this. So basically what this is like is it's kind of like a class, or a struct actually, in C. So we've got an ID, that's going to be 1. We've got a title, it might be get fish for this object. We've got a field called body, which is buy some fish from Woolies. And we've got another field called completed, which is a boolean which could be true or false. So what this means is this is an object which we have encapsulated inside of one variable. Now I'll give you an example of this in Node, just so we can sort of be on the same page. So your server's running. To stop it, just press Control-C. So I'm just going to show you what an object is. So var obj, whatever you want. If I say, this is kind of like a dict in Python, if you're familiar with that. A equals, oops, name, Nick, height, age, 20, God. So we've created this object in this variable, right? If I type just obj, it'll tell us all of the fields and all of the values. This is a field, this is a value. And if I go obj.name, it'll print out the value in that field. So very similar to a Python dict or a hash in Perl, if you're familiar with that. Allows us to mix together different variables of different types into one variable. So that's what we're going to use. This is kind of like our spec. What we're actually going to do is we're going to create another object that contains all of our to-dos and index them by the ID, because you can add fields to objects dynamically like this. So I can go obj.width equals 786, and now obj contains a new field called width. So you can add fields like that. It'll make more sense when we get into it. So let's start working out our to-do app, right? So the first thing we're going to need is we're going to need kind of like a list of what our current to-dos are, like the tasks that we haven't finished yet and we want to track. We're going to need some routes to say, when I access this route, I want you to give me back all of the to-dos that I'm going to do. And when I access this route, I want you to complete this to-do. And when I access another route, I want you to delete a to-do, for example. So our app is only going to have several endpoints. These are kind of like your functions. and those endpoints are going to be accessible by Emmet's app in Angular when we make it. So let's start by, getting back to this. So we've got our basic Hello World app, and what we're going to start with is creating a whole bunch of to-dos in an object, right? So we're going to make an object called to-dos, and we're going to have things like this. Let's say this is to-do number 1, and I'm making it a string, so do remember that. This is a string that we're using to index into our object. And we're going to put an object inside of our object. So this is going to be title, get fish, body, get that fish, and completed, false. So we've created one object. When we go todos.1, it's going to get this object inside of the object. So we've got two objects inside of the other. And this is just going to be an example, but we'll be able to list, add, and delete to-dos using API endpoints later on. So this is kind of like our data store for the moment. I'll move this up. So let's create one that will just give back all of the valid to-dos that we've got, right? So we're going to give back all of the IDs. So our expected input is going to be like nothing, and our expected output is going to be 1, okay? If we had to-dos labels 1, 2, 3, and 4, we'd want to output 1, 2, 3, and 4. So to do this, we're going to create a new route, okay? This is going to be only about 3 lines. So to-dos/list. Actually, you know what? We'll just call it list. So when we now go to /list in our browser, it's going to give back this response. Now, we don't just want to send back hello. We want to send back something, dynamically generated from inside of our code. Now, what we can do is we can get back all of the fields inside of an object in an array, which is something we're going to do now. So the way we do this is object.keys, and we're going to give it to-dos. All right. So what this is going to do, object.keys accepts an object, and it returns an array of all of the fields of that object. So in this case, if we give it to-dos, it's just going to give back an array containing the string 1. If we gave it this object here, it would give back an array that contains title, body, and completed. All right? I'll show you what this means. So when we access this, I'll run our server again. So it's now running. We go back to Firefox. Now note, our old route is still there, but if we go /list, it's going to give back an array containing just the string 1. Now this is actually rendering the JSON that it returns, but you might just get like a text output, or you might get an error. The error will show up in your browser. So what this has done is we've given back the list of all the to-dos. So this is going to be useful later on. Okay. Now, let's say I actually just want to get one to-do. I want to get back to-do number 1, right? So if we were just going to do this in JavaScript, if we were just going to like retrieve that value in the variable, we would go to-dos 1, right? So it's just like a dict. This is going to get back this object inside of 1 in to-dos. So what we'll instead do is we're going to make another route, and we have to use a parameter because we need to know which to-do do we want to get back. So we're going to use a parameter, and the way we indicate parameters is like this: colon and then the name of the parameter. Okay, so we'll just call that ID. So now, if I go to my browser and go /todo/7, it's going to access this route. So what we're going to do is we're going to go res.send to-dos ID rec dot. Oops. No, hang on. Okay. So let's unpack this a bit. we're accessing our to-dos object up there, and we're getting to-dos at the index req.params.id. So inside of our rec object, we've got another object called params. That contains all of the URL parameters, which are these, as another object. And so we can access ID and get back the parameter that we input, right? So I'll show you what this means. Console.log rec.params. So I'm actually going to print out the parameters that we get in each request so that we can see what is actually in there. Maybe you'll get a good idea of what this looks like. So now my backend is running. Let's go and go back to Firefox. Right. So we went to to-do/1, and we got back the to-do that was in that index, right? So we got back the title, the body, and the completed. So now if you imagine a front-end server, like what we're going to make, this could say, I'm going to go to this URL, and I'm going to get this to do, and I'm going to do something with this data. So I might display the title on the screen, or display the body, and display whether it's completed. So keeping that in mind, I printed out what was in rec.params. So we can see that there's one parameter, that's ID, and that was the only parameter that was given to us. So it's all in one object. Whoops. So I hope that's clear. So we can get all of our parameters using rec.params. So the last one we're going to make is we're actually going to do some task based on a URL that we're going to go to. So I'm going to go to-do/complete/ID. And what we're going to do now, what we're saying is this is to complete or uncomplete a to-do item, right? So if I know that my ID is in rec.params and I know that my to-dos are up here in this object, what we can do is we can go right ahead and go to-dos rec.params.id .completed equals true. So we're now actually performing a task and mutating some of the data on our server based on the URL that someone visited. Now, we do still have to send a response. So we should just say message it worked. And I'm doing this because I want it to be in JSON. I want to send all of my responses back in JSON. So this is good practice. So by doing that, whoops, yeah, I'll just say it's true for now. So by doing that, we're going to mark it to do as completed. So I'll show you what this means. So another demo. So what we're going to do, so we first list all of our to-dos. We can see there's one to-do here with the ID 1 slash. So let's check what 1 contains, right? This contains get fish, get that fish, and false. So it's not completed. Now if I go like this, we can see it worked. So it sent us back a response. Now if we go back and look at what we've done, whoops, yeah, sorry, to-do, completed is now true. And that's being stored on our server. So we can keep all sorts of state on our server. So if you imagine if you're making like a note collector, for example, you could attach tags and make an endpoint to say, oh, I don't know, attach a tag to this note, and you can hold all of this information on your server. It's very powerful. So the last thing we're going to do is now we need to actually accept data and put it onto our server. So you might be thinking, well, we could just put a bunch of URL parameters in, and we could. But there's a better way to do this, and we use a post request rather than just a get request. Now, to do this, we have to install another package. So I'm going to move really quickly now because I've gone a bit over time. So I'm going to go npm install --save body-parser. And so what this is going to do is it's going to allow us to read the post requests that are being sent to us. So that attaches that as a dependency for our package. And now we can use body parser. So when you're requiring something, it always has to be the name of the package when you installed it. So So what we're going to do, this is called middleware. We're adding in an extra piece of functionality that every request has to go through in order to be accepted. So by using app.use, we're setting up a piece of middleware. It's kind of like an intermediate layer between an incoming request and your server. Okay, so you can filter out requests and things like that, like this. So bodyparser.json, that means bodyparser is going to read the JSON and give it to you as an object. I'll show you what this means in a sec. So remember, we can accept post requests now by going app.post. So we'll go add and just leave it like that. And we do need to have a unique ID for each of our to-dos. So I'll go max ID equals 2, and we're just going to increment this every time we accept a new to-do, right? So the next one is going to be in 2. It could be title, get milk, or whatever. So need to remember how to do this. Yeah. So we're going to increment our max ID, and we're going to go equals, whoops, max ID equals rec.body. Okay? And so this is us inserting a to-do, and we're going to send back it worked again. And that's how we handle a post request. So rec.body, if we have body parser, is going to contain the body of the payload that was sent to the server. So when we perform a post request, which we can do with curl or Postman or whatever you like, we can actually get the body of what was sent. And so this allows us to add a new to-do to our to-do list. All right. So to recap, we can access URL parameters using req.params. We can access query parameters using req.query. So some APIs might want you to use query parameters instead. So that's when you get, like, if you've ever opened up Google or Facebook or whatever, and you look in the URL, you've got, question mark q equals and then a massive string. Those are query parameters. We can write our own middleware using app.use. This is something I didn't really cover, but it's something you don't really have to know. And you'll basically be creating functions that incoming requests are going to pass through. So we've done the post request, and we've done the completing that. So let's move on to Angular.
Okay, thank you. Hi everyone. Okay, so first off, who's written Python code before? Hand up. Who's written Python code that looks like C? Who's written properly object-oriented Python code? Okay, half of you are lying. Okay, so a lot of JavaScript front-end code can be written in a way that is very procedural and doesn't really follow an object-oriented sense. That's because JavaScript as a language doesn't have a lot of safety inbuilt into the language itself to constrain you to working in a way that's good and flexible for your code. So the goal of Angular and many other front-end frameworks is to actually provide you with this rigid structure that you have to follow in order to enforce you to make nice, flexible, and well-structured projects. So first of all, to install Angular, hop into your terminal, and using the Node package manager you would have installed earlier, you can type in npm install -g @angular/CLI. What this does is this installs the Angular command line interface, which is basically a tool you can use to generate new Angular projects. So, for example, where's your terminal? Just up?
Yeah.
Cool. Ooh. Let's cd out of this backend folder, or where we. Ooh, sorry. Okay, cool. And let's do ng new front end -new. So Angular is going to go off and do its thing and make a new project called frontend -new. This takes a while, so let's just go back to the slides for a second. So as you can see, it's just created a lot of new files, and it's going to start installing all of the Angular dependencies using Node. While that's happening, I'm going to explain the basic project structure. Can everyone see this clearly? Okay, most of you. Don't worry, we'll post the slides to you and you'll be able to review this later on. So, in our frontend-new folder, we're going to be presented with a lot of new files and folders. Most of these, as if you're new to front-end development, will be irrelevant to you. There'll be a lot of structure set up to create a testing framework, but you don't really need to do that if you're just making a quick web application. The most important folder in here is the app folder, which will be generated automatically. And inside this app folder, there's a lot of project-level configuration files. Then there's two very important files. The first being index.html, which is the top-level web page that will be served when you reach your Angular application. The second is styles.css, which is the global CSS style sheet that will be applied everywhere in your application. Who's written HTML before? Hand up. Who's written CSS before? Okay, yeah. Has anyone had great pains writing CSS before? Oh yeah, everyone that put their hand up for CSS also put their hand up there. So, inside this folder, there's a folder called source, which contains the source code for all your Angular projects. So, if I flip back into the terminal, it's still going. Wow. Angular is a big beast. Oh, rip your mobile data. Okay, so there are 4 files that matter to you in this directory. The first is called app.component.css, which contains the CSS code to actually manage your top-level app. There's one for HTML as well, which contains the basic structure of the HTML of your app. There's one called app.component.ts. Can anyone guess what TS stands for? Yes, TypeScript. So, TypeScript, as I said, oh yeah, ignore that. So, TypeScript, as I said earlier, is a dialect of JavaScript with the addition of static types. So, now that we have a language that actually needs to be compiled with types, Angular can give us a lot more warning information in order to help us write better code. So, the last thing here is app.module.ts. As you're creating an application, Angular will export this as a module, similar to how you create a package with npm. Inside this module, you'll declare all the dependencies that your application needs, and you'll also declare all the things that your application will export. Let's see how we're doing. Still going. Okay, so first of all, what's a component? So a component is Angular's bread and butter tool to structure your application. This is somewhat similar to a class in object-oriented programming. Who's ever used a class before in object-oriented programming? Okay, yeah, good. So, each component contains 3 key pieces, only one of which you actually need. The one thing that you actually do need for a component is the logic, which is the TypeScript. This contains everything to do with your class, including what parameters your class has, what values, what functions your class has, how it interacts with the users when it's clicked on, or anything like that. Coming with this is the document structure for your class. So the HTML. Each class will be will bundle together a certain piece of HTML. So if you're creating a class for a very special button, say, that prints a pop-up whenever it's clicked, you would write the HTML for the button, you would add the logic in the TypeScript code and link them together to make it so that when you detect a click on the button, it calls a certain function in your JavaScript and launches. So the last thing is style, CSS. That's completely not mandatory though, we don't need it. So together, they can all form a nested component tree, because your component that you create can use other components. What you end up is with a document structure, like an object-oriented like structure, that lets you build applications with nice componentized pieces of HTML. So you can recycle previous code that you've written in many places. And, if you're so inclined, you can share the code you've written as a module for other people to use. So what Angular is, it's just a bunch of modules that come with a lot of predefined components that have a lot of services, features, and functions for you to use. How are we doing with our? Cool. So let's have a look in our frontend-new folder.
Yeah, the touchpad is like...
Yeah, that's okay. So as we can see, there's a bunch of files here. What we care about though is source. So let's have a look in there. If we look inside this source folder, we can see that we've got our index.html here, our main.ts, which is the main TypeScript that will run. You don't really need to change this to make a small web application. There's also styles.css, which is the CSS that will be applied everywhere. If we look inside index.html, oh, damn you. Okay, Adam's got it. We can see that there's already some starting HTML here. All of this is just set up to initialize the page width and whatnot to match your phone or your or whatever application you've got. And down here you can see we've got this tag app-root. So if we cd into app, we can see that we've now got all these other files. These are the files that I talked about that were the bread and butter. Inside your app.module, we've got some import module code for Angular, but we don't have to worry about that for now. So let's actually open up this folder in Atom. Oh, thank you, Adam. So, and let's look at the main component. So this is the component TypeScript. We've got an app component decorator, which basically declares this class that follows as a component. Its selector is app-root. So when I make a HTML tag called app-root, it will replace that HTML with whatever this app.root is. It's got a template URL which links to the HTML, which is just the one in the folder. Same for the style. And then we've got our export class app component, which is the main class of our application. And we've got this variable called title, which we set to frontend new. If we go back to our terminal, we can see that we've also got app.html, which defines the HTML for our application. We can see there's some sort of image here. We've got a bunch of other stuff that we don't really need. Let's actually run our application. So when I type ngserve, Angular will compile all the files in our, ooh, there's a lot. It will compile every single TypeScript file inside our program. We can see that it took 7 seconds to do this. So unlike C, TypeScript is a bit slow to compile. And it's going to start automatically serving this on a web server. So,
Just hold down, go down.
I just want to make it a little bit bigger. So if we go all the way, that's very pretty actually. Right, all the way up the top, you'll see here that it says it's listening on localhost 42000. So let's actually click this link, which will open up a new page for us. This is our new front-end page. So Angular put in some pre-filled information here for us. Let's get rid of that junk. We only care about a small part of this to start off with, which is this part. So you can see here that inside my middle aligned div, if I zoom in a bit, we've got this welcome to angle bracket title, close angle brackets. Can anyone guess what this does?
Passes in a variable.
Yep, passes in a variable. And what's this title variable?
Frontend new.
Yep, so if we go back to our component TypeScript, we can see that we've got this title variable, which is frontend new. Angular will automatically link your TypeScript to the HTML, and whenever it sees these bracket tags, it will fetch whatever relevant variable that you talk about. So you can also do this with objects. If you have an object structure inside your class, you can do myObject.name.id.whatever. And the cool thing about the Angular server is that you don't actually need to recompile it every single time. If you just leave it running, you can see here that it compiled the bits I changed, which was just the HTML, and then resent it. And if we go back to our web browser, okay, we can't actually see it. So that means we have a bug somewhere. Let's have a look inside the console. Template pass error. Ah, right. So,
Yeah, so the good thing is that if you get an error in your Angular code, it'll show you in the browser's console. So you can go F12 if your code doesn't work. Usually it'll just show you like a blank screen, and you can see all the errors that may have been thrown.
right. So you can see here that I had an opening div tag to open my HTML, which was sent-ended, and I accidentally deleted the wrong div tag, and Adam annoyingly indented this properly, so it looks like it was normal. I instead had /ul here. So if I change this to /div. Angular will try and recompile. Looks like we've got no errors. And we've got welcome to frontend-new. How are we doing for time? Oh, we've got 5 minutes. So it doesn't look like I'll be able to show you how to connect to the backend today, but
We'll keep going.
we've got a lot of code online for you to use. So we want to actually create a component in addition to our main component. Let's shut down our Angular server. You can do this with ng generate, and we want to make a component, and we'll call it list item. List item. Angular will automatically generate this component, and one extra cool thing that it does is if we look in the module which declares all our imports and exports, it automatically adds this list item component to our dependencies. So we don't have to worry about importing it.
Even once you're after, so just keep going.
Alrighty. So let's look inside list item. We've got a bunch of files here. We've got the CSS, the HTML, and the TypeScript file. We've also got this list item.component.spec.ts. This is used for automated testing on the front end. You don't actually need this, so you can safely ignore it. Unless you want to do testing, which you should. So let's open up our list item. God damn you, Adam. If we look inside the spec, we get, oh, this is the wrong one. We want this one. So all we've got is the same thing as before. We've got a component declared with the add component tag. We've got an empty class with a constructor and an ng on init. So this ng on init function is special, and many of your components will use it. By importing the on init module, what it does is this function gets called once at the startup of your code. There is a slight difference between this and using a constructor, but today we're not going to care about that. So if we're going to make an item in our list of to-dos, let's mark that we need input into this class. I'll explain what this does fully in a minute. So we'll call this, say, task, and we'll declare it as a string. Nice thing about TypeScript is that we can actually declare things with types, so we get warnings if we make obvious errors. In addition to this, we're going to change the HTML to be something a little bit nicer. So currently, this is just a paragraph saying list item works. Let's change it to one list item, and we'll include the task. Thank you, Angular, Adam. Okay, so this task contains the task that was passed into our variable. So I've said that I need this at input here, and we can do this by importing input, which is a special module that we'll need. What this actually lets you to do is that you can pass in a value to fill in this string, much like you call a constructor, except you can do it in your HTML. So if we go back to the other Adam, pretty sure this is the one we want. Yep. And inside our app.component.html, let's actually use a list. So I'll declare an unordered list, just a bunch of list items. And inside this, I'll use my app-list-item. A lot of you might be asking, why is it called app-list-item? That's just the way Angular sets it up. Oh, we got back to the same place. So we want to actually pass in a value for our app-list-item to use as the task. What we can do is we can say item, or what would we call it, task equals, and let's say get that fish. Okay, so now we're passing in this get that fish value into the app.list.item. We leave our server running? No, let's start it. So if we go back to our browser, we'll see that it's waiting for the front end. Yes, okay, and we've successfully given one list item with the value get that fish. Okay, next up, let's make this a little bit fancier. So you can actually add logic to the HTML itself, which is kind of bound to the TypeScript that you write. So if I go back into my list item logic, Nice. Let's write some HTML. Some CSS, sorry. And we'll say, we'll create a class called completed. All it does is it has decoration. What is it called again? Text-decoration. Decoration is line dash through. If you had to guess what this was, you'd expect that it's just a strike through the text that you're talking about. So we'll go back to our component, and similar to how we actually interacted with the HTML doing a binding, we can say that class.completed to indicate that we want to conditionally display this class called .completed given a condition. So we're going to need to pass it some sort of Boolean variable to tell it whether it's not completed, whether or not it's completed. So if we go back into list item component, let's declare another variable. We'll say we have a private is completed. Ooh. And this is a Boolean. Ooh. One day I'll learn to type, everyone. Okay. And in our onInit function, we have to actually give this Boolean a value. We can't just have it sitting there on initialize. We know that the onInit function will be called once. So let's just assume that every single task will be false, will be not completed. So we say this dot is completed equals false. Nice. Then in our HTML, we can say this dot is completed. Very good. Is our Angular server still running? It is. And it's automatically compiled. It's given me no errors. We go back. Looks like this is completed. Let's change this to see what it says when it's not completed. So we'll assume all the tasks are always completed. True. Angular will recompile, and we can see that when it's true, the CSS class that puts a strike-through line through it will get applied. Alrighty. This is a bit tedious though. We don't want to just have it be true or false depending on which we typed in the code. So let's actually create a function. We can also say that when we click this class, or click this particular HTML item, using this round bracket bindings and the word click on the inside, and this allows us to actually write some JavaScript code in the quotes here to run. So we can say this dot, thank you Adam, this dot is completed equals not this dot is sigh. So all this does is, if the item is completed, then we'll apply the not, which means it'll flip true to false, and we'll store that in is completed. If it's false, we'll use the not, which will flip false to true, and store that in completed. So all it does is just flip the value inside. Let's have a look in our terminal. We've compiled successfully. Now, clicking this, we can see that clicking our list item actually toggles this for us. So now we've added some logic to our HTML. We're getting better and better. Right. So we don't want to tediously add some task every single time we write the code. We want to actually dynamically insert tasks into our list. So let's do that by going into our other Atom window. Thank you. This one? Okay. So we have an app list item. Let's add an input dialog. And we want to say, so similar to how we did click earlier, we can say onKeyUp.enter, which means when the enter key is released, we can do some sort of action. So what action can we do with this? We only have some static inserted list items in this. How can we dynamically insert these list items, right? So we need to keep track of all these list items that we're inserting. So inside our app component class from earlier, we'll have a let's call it tasks. And we'll say it's a array, just an empty array. So nothing in there for now. And let's create another function called add task, given a string called new task. And similar to before, we're going to push this task into the tasks list by doing this dot tasks dot push, and we can give this a JSON object like earlier. So imagine that in our server we've got a bunch of objects corresponding to tasks. We can say ID, for now is just null, and we'll give the value of this task, or let's say the body, as new task. Okay, now we can use this new add task function in our HTML. So on key up enter, I want to add a task using the function I created earlier, and I want to pass in the value of this input. To actually do that, we have to give this input an ID. So we can say task input, which will give the input bar the ID task input, and we can access this by doing task input dot value. Okay, so when I press the key up key on my input bar, it will actually add this task input dot value, into my task list. So let's go back to our browser. We've got this input bar, we type something in, we press enter. It will add that into the task list. But this isn't actually doing anything because we're not using the task list right now. So let's go back to our component, and we want to say for every task in the task list, we want to display that in our app list. So we do this using an ng-for, which is a for loop over a certain amount of items. We'll say equal to let t of tasks. Just check that I actually did call that tasks. Yes, I did. So now there's going to be multiple at list items inserted in this place, and each time the only different thing is that it will correspond to this t, to every item t in the task list. Now instead of passing in get that fish every time, we can pass in a variable, and we can do that by using the square brackets to indicate that you're passing in a task. And now we need to give it the name of the variable. Let's say t.body, because remember, in our add task, we pushed an item onto our task list that had an ID and a body. The body actually contains the string of the task itself, so we want to push the body of the task onto the list. Okay, that looks good to me. So Angular is not complaining, so we go back and we've got nothing there. Let's say hello. Heck hello. Okay, pretty good. We'll say this is a new task, and it's automatically added in. Let's do some cleaning up here to make this more presentable. So in my task list, we'll go back and say every time we add a new task, we also want to clear the text inside the input box, right? Because we don't want it to just be sitting there. We can do this by this task input, which is our input taskbar, dot value equals empty. So just the empty string. We're going to clear it out. Be careful not to get carried away here. We're writing JavaScript code in line with the HTML. In Angular, it's very easy to write an entire application with just one tiny class, and then you've got like 6,000 lines of JavaScript code inside the HTML. Don't do this. Whenever possible, try and abstract that JavaScript into your actual class. because otherwise you'll end up with an application that's just HTML, and it's no better than just writing raw JavaScript inside one giant file, and you're unable to track anything because it's just everywhere. Okay, one more thing to clean up. In our list item component earlier, we said that they're automatically completed. Let's just say they're not. Okay, what do you say, Angular? Angular agrees. Let's say hello. This is a new task. That's pretty good. And we can mark them off as done and not done by clicking them. Not bad. Let's take this a little bit further. It's a bit ambiguous to have just an empty bar there, so let's go back to our app component. We're going to also put in a button. This thing is very annoying, so we're going to slide it across a bit. So I'm going to create a new button using just the regular HTML button. And I want to say when this button is clicked, I'm going to do the exact same thing as before. I'm going to add a task that corresponds to new task.value, or task input.value, where task input is the input bar, and I'm going to clear it afterwards. And inside this button, I'll say add task to add a new task. What do you say, Angular? Angular's happy with it. We'll go back. Hello. So we can press enter to add a new task, and we can also say new task and click the button to add it as well. So we have multiple ways of interacting with our application. There's one final step to actually get this into a full-bodied working application. Can anyone guess what that is? Yes, we need to talk to the backend somehow, because if I refresh this, every time it's just going to be cleared. We want the backend to store all the tasks for my application, and we want our front end to actually retrieve these tasks every time. So, has anyone ever written JavaScript code to fetch something from a server? Has anyone ever done it without using a library? I see no heads nodding. Okay, yes. It's a bit more involved than the traditional way of just using a library. So we're also going to use a library today. And fortunately, because we're using Angular, we get to use Angular's libraries. So inside our app.module, we're going to require a new dependency. We're going to import a HTTP. I'm pretty sure that's capitals. Let me triple check. Yep, HTTP client module, and we want to grab this from @Angular to signify that we're getting it from the Angular standard library, common libraries, and HTTP. Okay, what do you say, Angular? Yep, it agrees that it's found that. And in our imports, we also want to say that we've imported this. So we'll grab the HTTP client module. Nice. So back into our component, we actually want to use this module. So let's copy across that import. The only difference being that here we're not going to use the HTTP client module. We're just going to use HTTP client, which is a class inside the HTTP client module. And we're going to create a constructor. Constructor, which does nothing, except it takes in a private variable called HTTP, which is of type HTTP client. So we're going to get a class called HTTP. This is a special notation in Angular to introduce a variable that you expect the top level app to generate and pass in for you. You don't have to worry about it too much. We also want to say that on init, we're also going to create the ng-on-init function as earlier, because we want that when our app starts up, we'll immediately get all the tasks from the backend and then fetch them to use them in our application. So the way we can do this is we'll use our private HTTP variable. Let's see what Angular thinks so far. Yep, compiling. we'll do this.http.get to indicate that we want to make a GET request to the server. So earlier, Nick wrote on the server that we can use app.get to indicate that when someone makes a GET request to a specific route, we want to respond. So we're going to introduce a server address. It's going to be a string, and we'll use this to make our life slightly easier. And this server address will be at http localhost and what port? 3000? Yep, 3000. Cool. So now we've got a server address that we're going to use. And to actually get stuff from this server address, we want to say this. We want to provide a HTTP GET with the address of the server we're contacting. So we'll do this dot server address, and we want to add which particular route, which I think was /list. Yes? Cool. So what Angular will do is it will go away and asynchronously perform this HTTP request, and this function, http.get, will return a promise saying that when this asynchronous request is done, I'll call you back. So we can subscribe to this promise, which means we can wait for its return value by using .subscribe. Okay. Earlier, Nick taught you about the two types of functions. It's more common these days to see this one, which is basically saying this is the function arguments. When I get given these arguments, I want to execute this part of code. So I'm going to expect some sort of response. And in that response, I'm going to get an array. As stated earlier, this will be an array of IDs of the tasks that we want to display. So we'll do a for loop. We want to say for. Ooh, that could have been dangerous. Var t task in response. So for every task in the response array that we got, we want to do fetch task. Actually, before that, we'll do something. We'll just say console.log, meaning we want to print it, and we want to say task. Task will be the ID corresponding to that task. So let's see what Angular thinks of this. We got some errors earlier, but it looks like it's happy with it now. And we need to actually run this server. So let's create a new tab. I believe I can do that with file, new tab. And where is it? I just made a new tab, so it's...
Yeah, it's in Backend.
We want to go cd programming. Yes, please. Oh, we're already there. Cool. So we'll cd into our backend new. Nope, wrong one. Dash new. And we want to actually run the server that we had earlier. So our index.js. We can do this with node index.js as earlier. So now our backend server is running in the background. Let's just let it be there and doing its thing. We'll start up our Angular again and serve, because we want to serve our front end. Angular is going to recompile and take its time, as per usual. Ooh, failed to compile. Let's actually take a look at this error. So, it says app.component.ts, which is our current file, on line 28. It said, close bracket expected. Let's have a look at line 28 down the bottom. Yes. So, I opened this subscribe function, but I never gave it a closing bracket. I did, but I entered a semicolon after these two function things, which I don't need to do. I'm just passing a function, not a statement, into this subscribe method. And Angular is going to redo its thing. Yes, okay, so we've compiled successfully. Okay, cool. So if we open up the console by going into inspect element.
Oh yeah, got a big clause.
Oh, okay. No, that's okay. So we have to do something called calls, which is basically enabling two different types of websites to talk to each other. We're going to get around this by using the one we developed earlier. We'll cd into backend, and we'll node index to-do.js. So the cause is a module that we need. We can install it by doing npm install, which, as Nick said earlier, installs all the dependencies or required things for this package. So now it's installed cause for us, and we can start up our to-do.js listening on port 3000.
This is the same. The URLs might be a little bit different, but it otherwise does the same thing.
So let's get rid of our console, open it up again. Did we refresh? We did not. Okay.
No, it's just...
Yes. So we also need to change the server URL because on our online server, the one we wrote earlier, it's /list/to-do. To-dos.
See what it says.
Yes, let's have a look inside this. I almost used Vim instinctively. You won't get me again. It's to-do/list, my bad. So we'll go back here, we'll change it to to-do/list. We haven't actually run the server.
To/list.
Yes. Pity the blind. Alright, cool. We've gotten our task backs, 0, 1, and 2. So earlier in this server that I made previously, if we go back to our terminal, or we made previously, if we look inside to-do.js, I've hard-coded these three simple values. 1 that has the value do Angular tutorial, 2 has the value get lunch, and 3 has the value relax. Okay, so we want to actually display these values on our front end. So let's go back to the code. So far, we've written a function to contact our server and give us back these numbers as values. These are just the IDs of the values themselves. So let's go to fetch. Let's make a new function called fetch task, which takes in an ID. And this function, similar to the earlier one, will do a get request. And we want it to go to /to-do. Now earlier, when we created this endpoint, we wrote the code such that when we pass in / and the ID of what that we're trying to fetch, the server will automatically interpret that as a parameter and then hand it back to us. So what we're going to do is we're going to do /to-do/get and then plus the identity we want. We're going to subscribe this as earlier by giving it a function. And we'll say this .tasks.push. We need a response. When we've got our response, angry arrow there, we want to add the response with the respective ID to our task list. So we'll do this .tasks.push. Woo. We want to give it an object with an ID, being the identity that we talked about earlier, and we'll give it a value, which is the response and the value encoded in the response. Let's see, pardon? Oh, we changed server.
Okay.
So Ah, yes. And to do this, because we're using TypeScript, TypeScript can't guarantee that response.value will be a thing. So we need to actually treat it like a dictionary and look up value in this dictionary. What do you say? Angular agrees? Let's give it a try. Oh yes, and we need to actually call our function. So, after we've done fetch task, we'll call, or after we've done this for loop, to grab every task in our response, we're going to do this, this dot fetch task. Yep. And we'll pass in the task that we received. What do you say, Angular? Angular is currently disagreeing with me. Did our server? Oh yes, we're not running the server. Okay, we've received 2 tasks, so it recognizes that we've got 2 tasks, and fetch task has tried to add them. Let's see what fetch task actually got in its response. So we'll have a look at the response. Okay, we've got 2 objects. One has the value do Angular tutorial, and the other has the value get lunch. Ah yes, sorry, Nick was right earlier. So this needs to be body because our HTML for app.component is looking for the body of a particular task. What do you say, Angular? Ooh, I'm not sure if any of you saw that, but we're about to see a working front end. Yes, we have our task. Woo! So, these are the tasks that we got stored on our backend. We've automatically fetched them using our front-end code. When we fetch them, we created new components every time, which bound the value of the task to the actual component. Some of you might be asking the question, all we did was push this onto the tasks. We didn't actually say to the HTML afterwards to reload the tasks, and this is one of the cool features of Angular. Angular will automatically watch this tasks variable when you do any sort of binding on it. Angular recognizes that we're using the tasks array here, and whenever the tasks array changes, we probably want to change the HTML as well. So Angular watches our variable, notices that it changes, that there's a new item in the tasks array, and will automatically render and push this new item onto our list. Okay, cool. That's all from me. Thank you, everyone.
Thanks, everyone. So yeah, all the codes in that Git repository we'll post in the event.